Alright, so I've got a second example here for us to try. And you can see that it's slightly different from the last example just because we have a minus in front of the x squared. But that's just going to involve one small extra step at the beginning. So let's just put up the rule that I had before. X squared plus 2ax plus a squared is just the same as x plus a to be squared, and that's a perfect square. So let's take the function, which this time is minus x squared plus 3x plus 5. And basically how we deal with that minus is we just take it outside a bracket. And what we're left with inside is the same function with the signs changed. Because if we were to multiply out that bracket again, we'd be left with the original function. We're never allowed to change anything's value. Okay, so now we're just left with a regular function inside the bracket that we can complete the square just as we did in the last video. So what do? We compare the number in front of the x, or the middle term, with 2a. So 2a in this example is equal to minus 3. So a is minus 3 over 2, which means our a squared is going to be 9 over 4. So let's write the function out again. F of x is equal to minus bracket x squared minus 3x. Leave some space for where we're going to do our steps. Minus 5. And what goes in this space? Well, it's our a squared. So we add on our a squared. But obviously we can't add on a constant without taking it away, or else we change the value of the function itself. And what we have here, the first three terms, that's our perfect square. So when we rewrite the function, we can write that as x minus 3 over 2, because a is 3 over 2 to be squared, and then we add the constants to give us minus 29 over 4. So we're almost there. The final step is just to multiply that minus there by everything inside the bracket. So we've got minus bracket x minus 3 over 2 to be squared, and then plus the constant of 29 over 4. So this is our function in completed square form. And that minus tells us that it's an n-shaped graph. And we can read the coordinates of the turning point. So it's going to be plus 3 over 2 is going to be the x coordinate of the turning point, and 29 over 4 is the y coordinate. So that's that one. Okay, so I've got one final example here for us to try, and this one is different because there is a number in front of the x squared. So we've got 2 in front of the x squared here. So our plan of action here will be to take out the 2 as a common factor, just like we took out the minus or the minus 1 as a factor in the last example. So we have our function f of x, which is 2x squared plus 10x minus 5. And I'm going to take out the 2 outside the bracket so that I'm left with a positive 1x squared to start with inside the bracket, and that's what we're used to dealing with. So what is left in here? We're going to divide everything by 2, so we have plus 5x minus 5 over 2. And now we can use the exact same method. So we're looking at the middle term here. So we're saying that 2a equals 5. That's the number in front of the x, the coefficient of x. So a here is 5 over 2, which means a squared is 25 over 4. So now we rewrite our function. 2 bracket x squared plus 5x, leave some space, minus 5 over 2, and in the space we add 25 over 4 and take it away again. So we're not changing the value. And the first three terms make up the perfect square. So we can now write the function as 2 bracket x plus 5 over 2 to be squared. And when we add our constants, we get minus 35 over 4. Now we can multiply out that bracket in our final step. So we get 2 by x plus 5 over 2 to be squared minus 35 over 2. And that's our completed square form.